One of our messages in the hands of the enemy may lose a battle. But if that message is cryptographed, the enemy will lose enough time figuring it out to make the information useless. To help you cryptograph more effectively, this converter, the M-209, has been put into use throughout the Army. There are several models of the M-209. All operate the same way. To see how, let's encipher the simple word "go." Whenever you encipher, be certain that the encipher-decipher knob is at C. Set the letter G on the indicating disc opposite the indicating index. Turn the drive knob as far as it will go. Set the letter O opposite the indicating index. And turn the drive knob once again. The result is the word "go" in cipher. Now let's decipher it. First, set the encipher-decipher knob to D. Next, reset the letter counter to 0. Set the letter X opposite the indicating index. And then the letter Z. Here's what we get. Our original word, "go." This system of cryptographing is known as cipher substitution, which simply means that different letters are substituted for the ones you set up. In this case, X was substituted for G and Z for O. This substitution is brought about by the interaction between the lugs on these drum bars and the pins on these key wheels. In order for your message to be deciphered, the pins and lugs of both your converter and that of your receiving operator must be set exactly alike. Charts are provided to tell you how to set them. Assuming that this converter is already set according to a chart, let's encipher this message. Set the encipher-decipher knob to C. Then set the letter counter to 0 by pushing down the reset button and turning the reset knob until the counter clicks into position. In order to make the cryptogram difficult to break down, 6 revolving key wheels are used. The first step is to rearrange them in any order you desire. Do this with your thumb or fingers. A hard object like a screwdriver will mangle the letters and ruin the wheel grooves. The 6 letters now lined up along this benchmark form what is known as the external message indicator. Since you'll have to refer to it later, this external message indicator is always written down. And here's an important point. You use an external message indicator only once in conjunction with a particular pin and lug setting. Now select at random any letter on the indicating disc. In this case, we'll take L. Record it along with the external message indicator. Next, encipher L 12 times. From these 12 letters, we have to form still another 6-letter combination, which will be the internal message indicator. First, reset the counter to 0. Then set the first letter, J, on the first key wheel. Set the second letter, W, on the second key wheel. But there is no W. A flaw in the machine? Not at all. Certain letters are deliberately omitted from the second, third, fourth, fifth, and sixth key wheels. Whenever one of the 12 enciphered letters can't be found on the key wheel, it's crossed out and the next letter used. Let's try U for the second key wheel. Yes, since it's here, we can use it. Next is P, which goes on the third key wheel. It, too, can be used. Now D. The next letter is J. Next is R. But R isn't on the sixth key wheel. So we cross it off and try the next letter, S. No S either, so it too is crossed off. Now let's try G. G's okay, so we'll use it. We have now set up an internal message indicator from the 12 cipher letters. Since we have the key wheels lined up, we must destroy the 12 cipher letters for security's sake. All right, we're now ready for the message. Set each letter on the indicating disc and encipher it. Notice that as each letter is enciphered, the letter counter registers. This gives the operator a check on the letters he has already enciphered and is useful in locating errors. The next letter, U, is already in place on the indicating disc. In such a case, turn the disc in either direction to release the drive knob. Then set up the letter again and continue enciphering the message. At the end of each word, encipher the letter Z. Later, when the message is deciphered, Z will come out as a blank space separating the words. Where a single letter occurs, use the phonetic name. In this instance, easy for E. This use of phonetic names for single letters helps to prevent errors in enciphering and deciphering and in transmitting. Since there are no numbers on the indicating disc, they must be spelled out. TWO for 2, and so forth. When you're finished, roll out a few extra inches of tape before tearing it off. Here's the enciphered message. Notice that the last group contains only 3 letters. Since the M-209 enciphers in 5-letter groups, it's necessary to complete this group by writing in 2 X's. Now we have to add 3 indicators that go before and after every M-209 cryptogram. The first indicator is obtained by repeating the letter we originally enciphered 12 times, the letter L in this case. This is known as the system indicator. and tells the receiving operator that the message was enciphered on the M-209. The second indicator is the external message indicator. The 6 letters we selected at random and set up on the key wheels before. Remember, we wrote it down for later use. This is it. The third indicator is the key list indicator, which tells the operator what chart to use for his pin and lug setting. Okay, we have our 3 indicators. The repeated letter, which tells us a converter was used. The 6 letters selected at random forming the external message indicator. And the key list indicator for the pin and lug setting. Notice that we separated the first 3 letters of our external message indicator from the last 3 to get 5-letter groups. All we have to do now is transfer the message onto the proper blank and then dress it up with the necessary information for forwarding. Finally, always turn the key wheel so that the internal message indicator is broken up. The message may now be sent to its destination by any of the Army's various means of communication. Ours is going by radio. Here it is arriving at another message center. Let's see how it's deciphered. The repeated letter L tells the operator that a converter M-209 was used. The key list indicator tells him which chart to use for the correct pin and lug setting. In this case, we'll assume that the converter is already set according to the chart. To decipher the message, the operator starts by following the identical procedure used when enciphering. He sets the counter to 0 and the encipher-decipher knob to C. Next, he picks out the external message indicator and sets his key wheels in accordance with it. Now he takes the repeated letter L and enciphers it 12 times. From this, he obtains the same internal message indicator that the sending operator used. He zeroes the letter counter then sets up each usable letter on the 6 key wheels. Since the letter W is missing from the second key wheel, he has to set up the next letter, U. Then he continues with the remaining letters. Here's the result, the original internal message indicator. Now he can start deciphering. First, the encipher-decipher knob goes to the D position. Then, beginning with the first letter after the indicator groups, he sets each letter in position on the indicating disc and deciphers it. When deciphering, the spaces between the letter groups are disregarded. All the X's at the end of a message must be deciphered because the receiving operator doesn't know whether they have merely been written in or are an actual part of the cryptogram. Here's our original message. Let's compare it with the cryptogram. It's obvious that the last two X's are meaningless, so the operator crosses out the corresponding letters. The letter Z, which we put in after each word in the original, comes out as a blank, thus spacing the words. Since it comes out as a blank, it must be filled in where it obviously belongs, as with the Z in 0. The last step is to turn the key wheels to break up the internal message indicator. And to destroy all work copies of the code, just as we did after N-ciphering. The message can now be transferred to a blank, dressed with the necessary information, and sent to the addressee. Now that we have N-ciphered and deciphered a complete message, let's go back and study in detail the pin and lug settings that are the key to the converter M-209. The pins for each letter on the 6 key wheels are movable. So are the lugs on the metal bars of the drum. The charts used to set up these pins and lugs are changed every day, so whenever a message is either sent or received, the charts must be checked for the proper pin and lug setting. These letters and dashes indicate the pin positions. A letter means that the pin goes to the right. A dash means that it goes to the left. Before making a setting, all pins must be moved to the left. Now that this is done, we can set them according to the chart. In the first column is a dash. Therefore, the pin of letter A on the first key wheel goes to the left. But this pin is already on the left, so you don't need to touch it. Letter B means the pin of letter B on the first key wheel must be pushed to the right. The same with C. The pin goes to the right. Be sure that each pin is pushed all the way so that it is flush with the side of the key wheel. An improperly set pin may slide into the wrong position and cause an error. Another dash. You don't have to move D pin since it's already to the left. Continue this way until all the pin positions indicated on the chart have been set on all the key wheels. Now you're ready to tackle the problem of setting the lugs. These numbers on the left of the chart, 1 through 27, represent the 27 drum bars. While these numbers here correspond to the numbers found on the number plate. For drum bar number 1, the lug positions are 3 and 4. Therefore, on bar number 1, the left-hand lug is moved into position 3. The right-hand lug is set in position 4. be sure each lug catches firmly in its correct position. For drum bar number 2, the lug positions are 0 and 4. Therefore, on bar number 2, the left-hand lug is moved into the 0 position, and the right-hand lug is moved into position 4. And so on until all the lugs are set. To make sure that all pins and lugs are correctly placed, you check against this group of letters at the bottom of the lug chart. It's called the 26-letter check. Here's how it's done. Set the counter to 0 and the encipher-decipher knob to C. Then turn all 6 key wheels to A. Now encipher 26 A's one after another. The result should match exactly the 26-letter check. If it doesn't, a lug or pin has been incorrectly placed and the positions must be rechecked against the chart. In this case, the letters check and the converter is ready for enciphering or deciphering. Now a few special points. First, the jamming of the machine. When the drive knob hasn't been turned completely, the indicating disc won't move. Complete the turn and the disc is free. Next, in resetting the letter counter, be sure the reset knob snaps firmly into place so that all the zeros are exactly in line. Otherwise, jamming occurs. The machine will also jam if a pin or lug is partly out of position. Then the converter must be checked thoroughly until the faulty adjustment is found and corrected. To put in a new roll of tape, release the cover and tilt it back. Then release the guard and pull it forward. Place the roll so that it will unwind counterclockwise. Thread the tape through the tape slot. And feed the end through the tape channel under the roller. Several turns of the feed knob will bring the tape into position. To replace the ink pad, push the spring arm to one side and remove the pad with the tweezers. Be sure not to open the fresh ink pad container over the converter. The ink may spill or the pad itself may fall into the mechanism. Push the spring arm to the side and slip the new pad in position. Both ends of the ink pad can be used, so when one end becomes dry, the pad is simply reset in the reverse position. About every 250 operating hours, the converter must be oiled. Again, don't open the oil container over the converter. An excess of oil may gum up the works. To clean the type wheel, use type cleaner with a brush. turning the disc until all the dirt is removed. Some models of the M-209 have plastic parts which should never be cleaned with chemicals. For example, this wheel. Use only a dry brush for cleaning such models. This reproducing disc shows exactly the same letter as that which appears on the tape each time a letter is enciphered. Should an operator run out of ink or tape, he can still cryptograph a message by recording the letters off this disc. Finally, if you're in immediate danger of capture, burn the signal operation instructions page by page. Then set all the pins to the left and all the lugs to 0. When this is done, destroy the machine with an axe or any other handy object. Rifle fire or a grenade will also do an effective job of destruction. Now let's have a quick review of the whole procedure of enciphering and deciphering. Assume the pins and lugs are set and checked according to the chart. The encipher-decipher knob is at C. The letter counter at 0. Set up your external message indicator. 6 letters selected at random that don't spell an actual word, and record them. Next, choose any letter, record it, then encipher it 12 times. Select the internal message indicator from these 12 letters. Then encipher the message. Remember that phonetic names are used for single letters, that numbers must be spelled out, and that the letter Z must be enciphered between words for spacing. When necessary, add X's to complete the last 5-letter group. Now, in the same order, before and after the text, write the system indicator, the external message indicator, and the key list indicator. Finally, transfer the message to a form and complete it. When you decipher a message, you begin by following the identical procedure used when enciphering. The repeated letter informs you the message was enciphered by an M-209. And the key list indicator tells you what pin and lug setting has been used. In this case, it's the one already on the machine, so you're ready to begin. First, set the counter to 0. Next, look for the external message indicator and set the key wheels in accordance with it. With the encipher-decipher knob at C, encipher the repeated letter 12 times. After this is completed, set the counter to 0 again. Select the internal message indicator from the 12 letters. Turn the encipher-decipher knob to D and decipher each of the letters in the cryptogram, including any X's at the tail end. Roll out sufficient tape before tearing so as not to lose any of the message. Z deciphers as a blank space, so fill it in where necessary. Transfer the deciphered message to a message blank, dress it, and then forward. And finally, break up the internal message indicator after each message is cryptographed. and destroy all work copies of the code tape. Converters are used under various conditions: at higher headquarters, in foxholes, in the open. Some of the conditions don't include tables or shelves. At such times, the operator can attach the converter to his leg by means of the carrying strap and have both hands free to operate it. When not in use, the converter is always kept in its canvas case to protect it from dirt and dampness. The converter is a valuable piece of equipment, but it's still equipment. In order to perform its job of confusing and delaying the enemy, it has to be carefully protected and properly operated. That's up to you.